Welcome to the Passion for Technology podcast. In this episode, we're diving into an article from our latest TQ magazine, exploring the fascinating world of human-machine interfaces. For more details, interesting insights, and valuable infographics, be sure to check out the show notes. User experience takes center stage in machine operation. Today, operating complex CNC machine tools requires several years of training and solid technical knowledge. However, the industry is increasingly suffering from a lack of suitably qualified skilled workers. Manufacturers are therefore counteracting this with intuitively operable machines. The latest machine tools are able to simplify operability through integrated feedback systems and the display of visual action prompts, so that even inexperienced operators can understand the handling of the machine in a short time. An example of this is the CORE operating concept of the machine tool manufacturer, United Grinding, which was awarded for its user and customer experience by the jury of the UX Design Awards in 2022. The core of the human-machine interface is a multi-touch display that largely dispenses with buttons. Self-explanatory icons simplify navigation through the machine menu and process steps. Each operator can configure their user interface individually. The user identifies themselves with an RFID chip with a stored role profile, and their interface is automatically called up. It was important to us that the new operation appeals to all generations of users, explains Christoph Plus, CTO of United Grinding Group. We therefore gravitated towards the operating concepts that are widely used in consumer electronics today, and with which practically everyone is familiar from everyday life. This increasingly includes wireless HMI solutions that can be connected via Wi-Fi and Bluetooth. They offer maximum freedom of movement and flexibility. There is also increasing consideration of dispensing with industrial hardware for machine operation and instead using standard devices from the consumer sector. It is already common practice today for machine data to be retrievable via an app on a smartphone or wearable. However, real operation of the machine is currently only realistic for non-time-critical process control, as consumer devices do not have the necessary security architecture to ensure functional safety. Given that smartphones and tablets are particularly captivating due to their ease of use, this technology could well determine automation in the near future. Voice-controlled user interfaces are increasingly being integrated into industrial HMI concepts, mainly in order to complement traditional graphical user interfaces. With the increasing accuracy and performance of natural language processing technology, machines can understand complex voice commands and respond accordingly. The company Voice Interconnect, for example, offers voice control for industrial applications as a ready-made kit. Real-time capability, AI-based semantic analyses and algorithms for beamforming and noise canceling ensure high operating comfort and audio quality. The system can also process acoustic feedback in the form of input prompts or text-to-speech for voice output. Thanks to local voice processing, the voice control does not need an internet connection and thus meets high standards of security and data protection. A natural extension to human-machine interfaces for machine tools could also be gesture control. However, the operation of machines via interfaces is very visually oriented, says Professor Katrin Wolf, head of the Human-Computer Interaction Research Group at the Berlin University of Technology. Hand movements are still rarely used for interaction. Professor Wolf says one reason for this is, it is uncomfortable for people to learn gestures and then perform them correctly without visual feedback or support if they make errors. In the WINK research project, Professor Wolf's team is therefore investigating how feedback can be given via tactile stimuli. For this purpose, the scientists are constructing special bracelets for the forearm that can transmit tangible signals to the skin. To do so, the researchers have joined forces with tool manufacturer Trumpf, who is providing the use of a laser cutter to make the work process more efficient. On one side, the operators push the steel plates into the industrial machine, and the cut parts emerge on the other side, where the employees check their quality. If they find faulty cuts, they have to go to the other side of the machine and record the findings via a keyboard. The idea, with a simple hand movement, such as a hook symbolizing OK, the employees could give feedback to the machine without having to go back and forth. Trump uses a bracelet from Kinemic for gesture recognition. It recognizes two-dimensional gestures based on movement, but only returns sound and vibration via a built-in motor. However, Professor Wolf's team wants to realize more complex vibration patterns and integrate more motors for this purpose. Although a prototype already exists, Professor Wolf is certain that the use of haptics for the control of digital devices will remain a research field for many years. We hope you enjoyed this episode. For more in-depth information on the latest trends and technologies in human-machine interfaces, check the show notes to access the latest TQ magazine, available free of charge.